Everybody, it's Miss Mac. Just coming in today to talk to you about what we call literal equations. I am going to be filling in a toolkit for you here. And then what's going to happen is you can either use my filled in toolkit that you'll have access to, or there is a blank one that you can pull up in Cami and fill out for yourself. This is a guide that you can use when you're doing assignments and assessments, so make sure you're paying attention. And if you have questions, ask your teacher. So, the first thing we need to know is what is a literal equation? And I have that filled in here. A literal equation is an equation that contains more than one variable. So, some great examples are formulas. In math, we have formulas like area. Area is pi r squared. You can see that there are two variables, one with the r and one with the a. So that makes this a literal equation. The one in green here is perimeter of a rectangle, 2 times the length plus 2 times the width. There are three variables in that equation, P, L, and W. That makes it a literal equation. So the next thing we need to know is how do we solve literal equations? Basically what we do is we use what we call inverse operations. Addition and subtraction are examples of inverse operations, multiplication and division. And basically what we are going to be doing is we are going to be using, and I'll add this in here, we are going to use PEMDAS backwards. So if you're sitting there and you're thinking, I don't know what PEMDAS is, PEMDAS is your order of operations. So we are going to be using your order of operations backwards when we solve these equations. So let me give you some examples. All right, well, so we're going to start out with some one-step equations, some pretty straightforward ones. So in each box, like this over here on the left, there's a recall statement, and then there is a problem. So we are going to recall something we already know and then apply it to a literal equation. So for this first one, it says, recall, and it says solve for x. So we're solving this thing for x. So if I look at this equation and here's my equal sign and I want to solve that for x, I notice I have this plus 7 on the left. So I would do a minus 7 on each side. These will cancel out and I get x equals negative 19. So I found my x by just rearranging and getting that 7 to the other side. So if you take a look at this next one, it says solve for a. Well, if you notice, we have the same kind of a setup, only instead of a true plain number like a plus 7, we have a plus b. Well, still, if I'm trying to get this a by itself, I have to get rid of this plus b. So I'm going to do a minus b on both sides. So what will happen then is I will end up with, on the left, A equals, and on the right, I cannot actually combine the C and the minus B, so I just go ahead and write C minus B. And so I have rearranged this equation to get the A by itself and have everything else on the other side of the equation. And that's all I do. When I solve for A, I get that by itself. Now, looking over here at the right side of this, so it says solve for y. So the first thing I do is I find my equal sign. I know my y is on the left. I have to get rid of the minus 9. So I add 9 to both sides. These will cancel out, and I get y equals, and I can actually do 34 plus 9 and get 43. So that's just a regular old solving an equation. If I look at the example down below, it says solve for d. Well, the difference is on the side with the d, I have another variable. I have e. So I'm going to do the same thing. I'm just going to add e to both sides. That will eliminate my e's on the left, and I get d equals. And I cannot actually add f and e together, so I just write f plus e and leave it just like that. That is solving that literal equation for D. Now, looking at some more examples. Right here, some more one-step examples. The one on the left says solve for x. And notice I'm taking -6 times x. So to undo multiplying, we divide both sides by -6, and that gives us x equals 5. So we actually could divide the -30 by -6 and get an answer. The one down below it where it says solve for r, you'll notice on the right side, I am multiplying 2 and pi times r. So I'm going to divide by 2 and pi, and then the 2 and the pi are going to cross out, and that leaves me with r equals c over 2 pi. And we just leave it rearranged like that. So all we're doing is rearranging these. When I take a look at the next example, it says solve for y. Now you'll notice in this case, the y is in the numerator of this fraction. This fraction being over -4 is like saying dividing by -4. And to undo, or the inverse of dividing by -4, is to multiply both sides by -4. When we do that, those -4s will cross out, and I get y equals -32. And that is my answer. Down here on the bottom, if I'm solving for m, I can see that my m is in my numerator of my fraction. I'm dividing by v, so to undo that, I multiply both sides by v, that's the inverse operation, and vd equals m. That is my equation. Okay, now moving on to two-step equations. So we normally think of order of operations, and we multiply and divide before we add and subtract. Well, when we're working backwards, we do those opposite. So we are going to add and subtract things and then multiply and divide. So in this one, it says we're solving for w. So the first thing I do, and another way you can look at it, is look what's farther away from the w. On the side with the w, I have this +2, then actually that 2 is being multiplied by the w, and I also have, we're adding this 2l on. So when I start with this problem, I'm going to start by getting rid of the 2l. It's furthest away, and I'm also adding it onto the w part. So I'm going to do a -2l on both sides. And that will give me P minus 2L equals 2W. Now I can get rid of the multiplying by 2 by dividing by 2. Notice I have the entire side over there, over 2. So I have P minus 2L over 2 equals W. And that is solved for W. Looking at number 6, it says solve for b. So if you notice where my b is, I have two things going on. I'm multiplying by this 1/2, and I'm also multiplying by h. Well, multiplying by 1/2 is the same as dividing by 2. So to get rid of this fraction right here, to solve for b, I'm going to do the opposite, or the inverse of dividing by 2. I'm going to multiply both sides by 2. That gives me 2a equals BH. And now if I'm trying to solve for B, I know that this H is being multiplied by it, so I'm going to divide both sides by B, and I get 2A over B. I'm sorry. I was starting to multiply or divide by the wrong thing. I'm solving for B, so I apologize for that. What I want to do is I want to divide both sides by H, so the H's will cross out. And I get B is 2A over H. All right, so it's easy to get lost in these. You got to be careful. Okay, we have one more slide we're going to do, two more problems, and they are both two-step problems. So if you look at 7 and 8 here, they are similar because they both involve fractions. But you'll notice on number 8, the entire right side is a fraction, and on number 7, just the P over 8 part is a fraction. So we're going to start with this one, and we're solving for P. So I know I have two things going on. I'm dividing by 8 and I'm also adding y. And the adding y is behind the fraction. So I am going to start by getting rid of the adding y by subtracting y. And this is going to be r minus y equals p over 8. And then since that's dividing by 8, I'm going to multiply both sides by 8. I'm going to write it right here. And I would get 8 times r minus y equals p. And that is my equation solved for p. Then lastly, we are solving for w. And I'm subtracting 10. I'm also dividing by e. The subtracting 10 is right next to the w, and then I'm dividing by e after that. So I'm going to start by multiplying both sides by e. That's going to give me es equals, those will cross out, w minus 10. And then to get the w, which is what we're solving for by itself, we'll add 10 to both sides. And what I end up with is ES plus 10 equals W. Now, what you're going to find is that no two of these kind of problems are alike. So what you're going to do is use your toolkit to find which ones are similar. They're not going to be exactly the same, but which ones are similar in setup, so you'll know how to go about solving. And again, the toolkit is actually filled in, and it is in Schoology, so you're welcome to use it. Like I said, you can print out or get a copy in Cami of the blank one and fill it in yourself, or use the one that's already filled in. Good luck with this, and make sure you ask if you need any help. Thanks. Bye-bye.